Hi, I'm Luca Mustafa from Institute INAS and I'm introducing ToslinkCNC. So ToslinkCNC is an idea we had that instead of using optocouplers and very shielded and complicated wiring on low-cost CNC machines, we could use very affordable fiber optic cables and thus transfer all the electronics to the stepper motors themselves, so having a driver and the control board right next to the stepper motor and supplying it only with power and control signal via the optical cable. So here in front of me is the second version of ToslinkCNC at the moment in a default configuration as we see it. And this is identical as used on our Good Enough CNC hybrid machine, which is a very low cost CNC everyone can build. So just briefly looking at how this works is we have a transmitter board which consists of an Arduino, a shield that connects the Arduino to our ToslinkCNC main board. So the main ToslinkCNC board is the same for transmitter and receivers all along, and it features a few things. So once used in the transmitter configuration, we have two transmitters on it and a CPLD connecting through a Raspberry Pi compatible interface to either Raspberry Pi, Arduino, or Planet CNC controller. And in a different configuration, this is a receiver board where we have two transmitters, one receiver, so signal can come in and go out twice repeated, a CPLD as a core around it, and a connector featuring step direction enable signals that can be interfaced with pretty much any stepper driver out there. Additionally, there are inputs and outputs, so we can say trigger a spindle or actually have a limit switch connected to this once supported in the firmware. So let's have a brief look at how this all works and just do some simulation. This is a good setup for testing this system prior to assembling it on a machine. So over here we have a power supply. So this is just a normal mains to 24 volts power supply, and from there we have power cables going to every stepper driver. So we have 1, 2, 3, 4 stepper drivers with power just being split. And as simple as that, we bring power to every stepper motor. The control flow is as follows. We have the transmitter board, which talks to the computer. So in this example, we're using LaserWeb2 as a control interface. Say we want to move a motor, the G-code command is received by the Arduino. This is converted to step and direction. With the ToslinkCNC, this is all put onto a fiber cable, which then goes from the transmitter to the first receiver. Now, this first receiver takes the signal and based on the microswitch configuration here, selects which axis this is. So the one in front of me is y-axis in this case. It puts the y-axis motor signal to the step driver and the motor will turn. But as well, there are two fiber cables going out, one to the other Y stepper motor, because in our Good Enough CNC configuration we have two of them, as well as then to X motor and the Z motor. You can see that we're using NEMA 23 and one NEMA 17 motor in this case. And once we set the configuration like this, we can test everything works prior to installing it into a CNC. For example, we can say, okay, let's move the y-axis, and we see that the first and the second Y motors move synchronously. Jogging X, for example, turns this stepper motor as if we have it on the x-axis, and likewise the Z motor turns as well. So the flow in this case does not use the back loop yet, so the feedback using limit switches, but we can take the spindle enable signal and we can receive it out of every receiver board, meaning that if we have, say, a laser head on a machine, it's usually very close to a Z motor if the motor is actually on the axis. Then right from the ToslinkCNC board we can connect to our head laser or spindle and just enable it like this. So the advantage of this whole system is that we get rid of all the complicated shielded wiring and put everything on a stepper motor, connecting only signal over a fiber optic cable, normal ToslinkCNC, and just a pair of copper wires to deliver power through 24 volts DC can be used with 12-volt systems as well. So this is a very brief overview, just moving it once again to show everything works fine. And in the next video, we'll show how this operates on a machine. ToslinkCNC wiring from transmitter, signal goes to Y-axis receiver. There's a receiver and it repeats the signal twice, one going to the other Y-axis and the other going to X-axis, and from there on to Z-axis. And that's how all the motors and stepper drivers get the signal from a single transmitter by a single optical fiber. Testing the Toslink control system, we can move the Y-axis. We see that both Y motors move, and this is because Y-axis is selected on both this ToslinkCNC receivers. We can move the X-axis, it's selected on this one, and this one will move. Likewise, we can move the Z-axis, which moves here as well. And this features a fully working ToslinkCNC system.